Well, good afternoon, everybody, and welcome to the second of today's webinars from Smart Vision Europe. In this one, we're looking at data cleaning with IBM SPSS statistics. In the previous webinar, we looked at a sort of introduction, if you like, an introductory webinar to IBM SPSS statistics. Here, we're really focusing on problems associated with, the kind of maintenance of data and trying to clean up and get data in shape. It's a kind of necessary process that everybody has to go through at some point when they're working with data. My name's Jarlath Quinn. I'm an analytics consultant at Smart Vision Europe. If you haven't joined any of these sessions before, you should be aware that they're recorded. In this case, quite useful for have it recorded because I will be jumping around and showing lots of different techniques and approaches that one would take. Kind of miscellaneous bunch of different procedures. So if you are interested, you think any of them useful, you may want to use the recording to check exactly which menus I'm clicking on, etc. And there's a little bit of slideware here. Again, most of it's a demonstration, so we'll email out a copy to you after the session's ended, and you'll be able to download them. And again, if you find it really useful for colleagues who are unable to attend, you get enough of them together, then it may be possible for us to arrange a rerun on a private basis. The best thing to do is just to email us. We do get questions as we're going along, but we can't hear you. So all the lines are muted. We ask you to use the chat panel, and my colleague Rachel will try and field those who's also listening online as we're going along. If I run out of time, and there is quite a lot to get through here, we will follow up with you offline. But again, you may want to send if you send us an email afterwards. We're very happy to deal with those, and we get emails usually after each session anyway. So it's no problem to do that. And if you don't know who we are Smart Vision Europe. We are a gold accredited partner to IBM Predictive Solutions and Data Robot. We're an analytics company, and we specialize in statistics and data science and machine learning and I guess AI. But we also work with open source technology such as R and Python. And we're a relatively small organization, but we all have very deep experience of working in the analytical software and tech business, stretching back over 30 years in my case, and working for SPSS and SAS and IBM, as well as Smart Vision. And that means we've all got a very deep experience of applying not just things like statistics and SPSS, but lots of other tools and techniques and the procedures and platforms to many different vertical sectors and many different applications within those vertical sectors. Most of you work in sectors that we've probably done. We've done work in those sectors. We've probably done training or consultancy or written webinars that address specific problems that are pertinent to those areas. We may even have worked in some of the organizations that you come from. So we're very well placed to talk about age-old problems like how do you clean data, and this is a common problem that pretty much everybody has to deal with when they're working with analytical software. Um, Errors and problems with data. Let's get straight into it. Data cleaning is, as I say, an almost universal problem for anyone who works with data. And just a bit of context around it. Obviously, irrelevancies and errors in data can occur due to making mistakes. You do get data input mistakes. You do get inconsistencies in the way in which things are coded, particularly when you're analyzing big databases and things have changed over time. You get different data entry operators or different teams of people that record things differently. You get information that's collected on non-applicable events and subjects. So you often just have to filter stuff out. That's just not relevant to it. Sometimes just the business of extracting the data can lead to information being missing, mismatches between database tables when there isn't information available for certain groups, and differences in the way in which the systems themselves encode or represent data, such as date or time fields. That's just a common bugbear. Every system seems to have a different way in which it encodes a date field or a time field, and pretty much every system tries to deal with every other system's way of encoding date or time. But it is a tricky problem, and it is a few with each platform will have its own ways of dealing with it. SPSS is no different. In fact, as I'll show you, it's got its own wizard to deal with date and time fields. You certainly help with trying to format them correctly. So challenges you will encounter are things like identifying records of fields with a high percentage of missing values or a high degree of variability or sometimes too little variability. I'll often get handed data sets where you get one or two columns where there's just no variability. It's the same value over and over again, which is obviously analytically useless. Or correcting values out of range. People who are, supposedly aged 199 years old are employed with minus numbers, employed for -7 years. Duplicate records are another thing that happens over time. Ensuring variables are correctly formatted. So things like removing decimal places from age or making sure that the system understands that this variable is a number or this variable is a category. Checking that the values and combinations of variables do not contradict each other. There may be no mistakes in the columns or the variables or the fields themselves, but you may find that the relationships between them indicate that there are errors, such as, car drivers that are 15 years old or something like that, or men that are pregnant or something like that. Um, Creating syntax to correct data issues automatically is something which we will touch on as we're going through it. And it's something which, if you are dealing with regular problems of data cleaning, then familiarizing yourself with SPSS syntax, which is very easy to get to grips with, and which we actually have our own webinars on and recordings on YouTube off to get you started. Lots of information on our website about that is a really good investment of your time because a lot of data cleaning is repetitive in nature, and one of the things that syntax is really good at is it allows you to apply the same procedure to multiple parts of the data and multiple fields at the same time. So rather than doing it on a piecemeal basis, it can really clean up, increase your efficiency. And of course, it allows you to record the work that you're doing so that if you're dealing with very similar data sets in the future or regular data sets that you're extracting from a third party system, you can just rerun your cleaning syntax to get it into shape, and that really is a big bonus with regard to efficiency and productivity. So there are two broad classes of data errors, and in SPSS, most of these fall into one of these two categories. One is problems of how the data has been formatted or imported. So this would be issues, as I say, things like data time variables, things like identifying what values are non-legitimate, such as not applicable or unknown values or out of range values. These are missing values. Applying proper labeling to data so that you understand what the categories are. Making sure that the nature of the field is correct. So you'll get fields which are in strings, but really they should be numeric because you need them to be number fields in order for them for you to do the analysis you want to do, like a correlation or something like that. And variable names, you often get issues when you import data and the variable names are just so long that they're really quite awkward to work with. You want to try and rename the fields to make them more transparent, make them easy to work with. Then you have problems with the data itself, where you have actual errors, defects in the data, where you obviously need to be fixed. You have irrelevant values or variables or records, stuff that needs to be deleted or removed. You get inconsistencies, 15 different ways in which a region like, Birmingham or London has been spelt or recorded. You get duplicates and you get illogical relationships. And that's, again, it's just really just scratching the surface there. We're not, there's many other types of issues we've got to deal with. But obviously, as we work through this webinar, we're going to be addressing each and every one of these typical types of problems that one might encounter, as well as touching a little bit on syntax to show you, just to give you a touch of how you can build up a syntax job, which can really increase your efficiency with regard to dealing with these problems. Okay, let's start with data formatting problems. If I jump out to the data set that I've got here, I've got this data set. This is the employee data set. I talked about it in the procedure in the previous webinar. It's a very useful data set. It's pretty much the first one I go to. It's been around for many years, and one of the reasons it's useful is because it's got a really good mix of field types in it. So if you were testing something out, it's a good data set to go for. Everybody understands it because each row is a different employee. and the variables make sense, you know, their beginning salary, their current salary, their previous experience, the number of years of education they've got. Most people try to can kind of get their head around that. And it's got a lovely mix of fields, so mix of category fields and continuous fields. So you can use it for demonstrating lots of different procedures and testing out lots of different procedures. So it's a good one to familiarize yourself with. And it's got a nice story behind it, how it was used in a court case where some workers in a bank in Chicago in the 1980 or something like that had brought an equal opportunities case against the bank, and I believe they won. So it's good on many different levels. We're going to start with just issues around formatting. Let's look at formatting. So one of the first things we get here is very often when you read data in through a third-party system, let's say it comes in through, I don't know, Excel or through a database or somebody sends you a CSV file or whatever, you'll read data in. If it doesn't have a field header, if there isn't like a field header for that, SPSS will just assign it a field header. So if I just create a data set here, if I just create a field here, I click in here and I say, okay, I'm going to put a one in there. You can see it calls it var0001. So it starts calling it a name. It's not very useful. It just means variable one. So that's not great. So you here we've got one that's called var001. And that's not very descriptive. So obviously we want to change the name of that. So I could just change the name of that by just, again, you'll see me doing this a lot. Just double clicking on the header will take me to the variable view where I can change all the formatting of that variable, what's called the dictionary information, and give it a new name, JobCat. Yeah, so that's easy to do. You should be aware, however, that there is syntax that does that as well. So I could open a syntax window here, and it's very, very plain English. And the SPSS syntax was originally designed to be kind of plain English commands. So, as you can guess, what this command does, rename variables, is simply rename variables, and you usually put brackets around it. I'm gonna call jobcat something else like job group, and I'll change it again. Jobcat equals job group. Put a full stop in the end of it and run it, or click or run that selection or run all. I run all here, just run everything. And when I come back here, you can see now it's called job group. Why is that useful? Because if you want to rename a whole bunch of fields in one go, you can just list them all on one side of that equal sign and then the new names on the other side of that equal sign and have them on, or even have them on different lines in the code. It's not very fussy. It's a much faster way to do that. So I'm going to change this back to JobCat because that's its kind of standard name. So that's just something as simple as renaming a field. Very easy to do. What about an issue here where we've got two different fields here, but they're actually measuring the same thing, or different aspects of the same thing. This is people's current salary. This is people's beginning salary. Well, you can see here when I right click on beginning salary, it knows how to give me descriptive statistics for that because it's been correctly formatted as a scale variable. That's a number variable. And it gives me some mean, median, minimum, maximum. Whereas its neighbor here, which is current salary, which is ostensibly measuring the same sort of thing in the same units, that's got a different symbol at the top. It's actually been accidentally read as a nominal field. That's a category field where each value is a separate category. And that means when I ask for descriptive statistics of that, it tries to give me a frequency table showing me the percentage occurrence of each of these inverted commas categories. But in fact, they're individual numbers. So I want to change that. This is a very common problem. So I'll double click on that and change the measurement level to scale. So you can do that. Again, there is some syntax which will allow me to do that. If I go to syntax here, I could add in another command here and I could say variable level is the command. Brackets, and I'll call it, let's just muck about with it. I think it's Sal begin. Look at that, it's guessing which field it is. Sal begin is actually, I'm going to make that ordinal. Sorry, put the brackets here in the wrong place. Ordinal. Ooh, you should bear in mind, by the way, if you forget, as I often do when I'm typing this stuff, if you kind of get started, if you know roughly what the command is, and you get halfway there, if you highlight it and click on the syntax help button, it'll always take you to the help system, and it always shows you a little example just to show you the formatting of it. So if you just click on that, there's the variable level command that's just pulling up there. So it shows you a few examples. There's variable level for sales 95 and sales 96 all being scale. Here's region and division. They're being nominal and expenses being ordinal. So you can do a whole bunch of them in one go. That's useful to know about. So here I'm changing beginning salary to ordinal, which is a rating scale type thing. There it is. It's changed it to ordinal, and I can change it back here to scale. So again, just bear in mind that these commands, these formatting commands, can be done via syntax as well, and that's useful. It makes things often a lot more efficient if you have to apply them to many different fields at the same time. And what else could we got? Well, as you can see, I'm generally going through this data set here, right-clicking on stuff, going descriptive statistics. One of the reasons I do that is I'm looking for errors. I'm just checking it, just kind of poking the variables and seeing what to look at. If I get to age here and just do descriptive statistics and that, I notice something odd about the variable age is that the minimum value is -9 and the maximum 62, and that will affect the mean. Well, there are three missing values in there. Those missing values are what are called system missing values. That means they're just nulls. That means they're just empty cells. And in the numeric field, an empty cell is just filled with a full stop, a period symbol. But there's definitely some values in there of a -9. On top of that, I'm guessing that these -9 numbers are what we call user missing values. These are special codes that we give to a variable or to the data set to indicate that that data was missing. And sometimes you have more than one user missing value. You might have one for, in a survey, for example, for refused answer, not applicable because they're not doesn't apply to them, or just missing. We don't know, didn't answer that question or whatever. So that's why when you double click on the header here and it takes you to that row or that field in the variable view, and you get to the missing property here, you can see that you can have up to three different discrete missing values, and it's often you'll see -99, -97, -96. It's a common convention in surveys for, not unknown, not applicable, and refused or something like that. And they're just called these -99 and -96. It could be given any number, but usually something that sticks out. So in this case, it happens to be -9 sticks out. So we're going to say, by the way, I'm thinking -9 here, age of employee is actually a missing value. It certainly isn't their age, obviously. If I right click on age just within here, within the variable view, and ask it to run descriptive statistics again, we can see that now the minimum value is 20. Minimum age is 20 and the maximum age is 62. That seems a lot more sensible to me. And we have 6 missing cases now rather than 3. So that means that 3 additional cases must have been coded as -9. Okay. And that will affect, of course, the mean because when they're identified as missing values, they're taken out of the calculation. So the mean now changes to 34.73, whereas 400 was 34.45. And the range is different, the minimum maximum is different. So we've kind of fixed that problem. Again, if I go to syntax here, I've got a command, of course, as you would guess, simply called, as you might have guessed, missing values. And you can put in a range of different fields here. I could put in age here, and I could say, I don't know, -8. Maybe there's another missing value in -8. Sorry, full stop and parentheses. That's also a missing value for age. Hit run that, click that. Let's go across. Let's look at age now. Now the missing value has been set to -8. You can't set more than one. You can't do that, but I'm going to change it back to -9 at that point. Oh, by the way, -9 doesn't have a value label associated with it, so you could actually give it its own little value label and say, look, -9 is simply unknown or refused or not applicable or whatever, or something like that, or pending. You might get something like pending. It doesn't matter. Just the fact that it's got a label just makes it a little bit cleaner. And again, once again, there's a command called value labels that allows you to attach value labels. Very useful when you have a lot of fields that have the same value labels. What sorts of fields have the same value labels? Rating scales, where you've asked people, how much do you agree if the following statements? And they've all got the same scale of from strongly disagree to strongly agree. So you could apply the same value labels to them through syntax to them all at one point. Okay, so we've got other stuff here. I can see that the variable job time here That looks like a number field to me. It's got little X's in it. That looks a bit odd. If I hit descriptive statistics on here, you can see that that's actually the months entire. That should be a scale field. If I double click on that and change that to a scale field, look, it won't change it to a scale field. Why is that? Well, that's because if you look, if you notice it, there's a little A symbol next to it. That A indicates that this has actually been read as a string field. It's a character string field, and we definitely know it's a character string field because we can see that these values of X in there. Now, if I force it to turn it into a numeric field, that means, don't read it as a string, read it as a numeric field. Those X's will be turned into system missing or null values of the full stop. So they'll be destroyed. That data will anything which isn't a number will, it could be A, B, C, D or anything, will just be turned into a missing value. So if I'm okay with that, I could simply go here to type a field. Here's all the different field types. Change it to numeric. It doesn't need a width of 16 because it doesn't have 16 characters. I'm just going to width of 3 in case somebody's been there like from, I guess, over 100 months or something like that. Click OK at that point and then go back to it. You can see now, look, these have been removed and it's now a number field, but it's still set as, because it was previously a string, it wouldn't let it be a scale level. So I'll change it to scale level. And again, if you needed to do this, if you needed to change something, like if I change this back to, just for the hell of it, I change it back to string again. Obviously the X's don't come back because we've destroyed that data by changing it to numeric. But we could run a syntax command. There's a syntax command here called alter type. Okay, and that helps me change the type. If I hit the help button on that, it'll just take me to that, and I could see a little example of alter type, how to change that. So alter type var list, you could have a variable list here, a little example here. String date 1 to string date 2, make them all date 11, etc. So just a little trick here. You need to know that if I go alter type, what's it called? It's called job time, isn't it? Job time. There you go. So you can see me typing job time, and I'm actually going to make it F3. F3 is, believe it or not, F stands for number. It means floating point numeric. That will change it back to a number. And there we can see it's actually been changed back to a number, and we need to change the scale back to scale again and back to how it was. So you can do that through syntax as well. Okay. Okay, you will get situations where, you say, look, I've got a load of missing values in here. I just need to fill them in. I just need to get rid of them. I just need to put something in there. This is particularly true if it's a string, if it's a time series. If each one of these records was, different value, I don't know, sales or something like that every week or something like that, or, something each month, you will get, sometimes you just get data where it's just missing. And you can just plug in values in there. There's something called um, uh, the, uh, uh, the replace missing values under the transform menu here. You can go to replace missing values. And that allows you to put in what's called the series mean, for example. So I could pick up months since hire, which is job time. Is that job time? Yes, job time, yeah. And it's going to create a new field here called job time one. So I'll call it job time. I'll call it impute, meaning that or replaced or something like that, just to make it obvious. And you can see it replaces with the series mean or the mean of the nearby points if it's a time series. You might want to say, well, just take the most recent data. Click OK, and that will create a new field for you. Look at this job time there. Notice it's got decimal places because when you create a new field, it makes it numeric 8.2. So I could go in here. Oh, it's actually make it numeric 5.1 in this case, but the default is 8.2. I can say, yeah, let's make it 3, and we don't need any decimal places in there with the 3, no decimal places. And I could delete this one now, couldn't I? And I can drag this one around, but it's right there where it was beforehand, and I could relabel it so it says just job time. It's given it a label SE mean job time, meaning a series mean job time. I should probably change that back to months since hire. Now, the key here is that all of this can be done through syntax as well. And you might want to do that if you have to do it to multiple fields at the same time. But there we've kind of fixed that. Okay, so these are issues with our data formatting that we've encountered thus far. What about actual problems with the data itself? You know, these are kind of problems with the data itself, with the values in the data rather than the formatting, rather than with how we've read the data. Well, it turns out we've got a procedure in SPSS that helps us deal with problems with the data itself. I'm just going to close down the output window here, just because it's getting in the way. And do I want to close down syntax? Yeah, I'll close down syntax. I don't need it now. I'll come back to it later if we need to. We'll close this down to get a nice clean output, and then we'll move on to the next section here. Under the data menu, you've got this little subtle menu here called validation. And this is part of the data preparation. We used to be the old data preparation module, but it is now it's now part of the base module. So they rolled it into the base, so everyone gets it. And you'll also notice it's got things like identify duplicate cases in here. It's also got identify unusual cases in here. So it's kind of anomaly detection. But under validation here, we've just got this procedure called validate data. Now, if you click on validate data, it says, okay, well, what variables do you want me to take a look at? Well, if you've got a case identifier variable, and you can create these in SPSS, you can create them through the compute menu. Very easy to do. But in this case, it's the employee ID. I'm going to say that's my case identifier. I've got a unique ID. Why do I want that in there? Because it's going to help me identify any duplicates, anybody with the same unique ID. And I want to have a look at everything else. You know, I want to have to have a look at all the other fields. What's it going to do? Well, it's going to run a bunch of basic checks. If I look at this next tab over here, it's going to flag any variables that will fail any of the following checks. So any variables where more than 70% of the data is missing, any variables where more than 95% of the data belongs to a single category. It's not uncommon, of course, to have, 5% of the data in one category and everybody else to be in another category. So you could change that to 98% if you wanted to be a bit more strict. If you think, well, that's a bit much. The maximum percentage of categories of a count of one. Well, if 90% of your data all have categories of a count of one, then it's probably not a sort of analytical field. It's probably something like an email address or something like that. It's probably some identifier or their postcode or things like that. This is called high cardinality. It means that they're all individual and unique. They're not categories. So that's just pointing out any fields that belong there. Anything which has no variation, coefficient of variation or minimum standard deviation, they're both measuring the same thing really. Applies only to scale variables. Flagging incomplete IDs, any cases where the ID is not shown. Flagging any duplicate IDs. Flagging any empty cases where you define cases by all the variables except the ID fields. So this is useful. So it's basically doing a whole bunch of checks for us. And you can actually ask it to, as well as giving you a little report, ask you to save out some fields for you that indicate, because if it's a really, really big data set, you don't want to be manually going through and finding all of these problems. This will just create fields for you that have problems. And then you could use, as you'll see later on, select cases, something like that, which is a filter command to get rid of any or sort the data in order and just delete the fields that violate any of these rules. So I click OK at that point. It goes off and it finds some problems here. So it says, okay, look, you've got cases which are constant. More than 98% of the data belongs to one category, and that variable is city. So look, city of Chicago. Let's check it. Look, there's three which are blank, but everybody else is in Chicago. Well, that's not very useful to me, so I'll just delete that. That's the first thing I want to do. Did that, so that's one of the first things that's identified for me. It's also said, let's see, you've got cases containing containing one case, basically unique cases. That's date of birth. Okay, so date of birth has a very high cardinality, so that means it's got a lot of unique values. Well, we'd kind of assume that with date of birth, wouldn't you? What would I deal with? How would I deal with that? Well, it turns out that that's because it's been read as a string field. We can see it's been read as a string field. It's got this little A symbol, and that's very common with date fields. You're going to get stuff that's read as a string field. What could I do? Well, I could chance my arm. I'm going to chance my arm here. Let me just say, I'm going to insert a blank cell here. I'm going to make a copy of this and paste it. Look at that. I'm just pasting it just across it. It's no, so it calls it var002. So I'll call it DOB2. You could try this. Doesn't always work. You could try this. You could try just forcing it to become a date field by changing the type to date. And if I do that and see if it works, well, would you believe it? It's actually worked. I knew it would work, but I mean, because I've done this before. But sometimes you get away with it. And if it looks right, it's probably it's worked, and it's even good given a little date symbol. And you could make it. It's not really a nominal field; it's more of a scale field because it's kind of a number field. But there, that's worked. Sometimes though it won't because the formatting is just it's just something it doesn't understand. In that case, you'd go to transform and down the date and time wizard. If you go to date and time wizard, you can go to create a date and time variable from a string containing a date and time variable, create a date and time variable from variables holding parts of dates and times. You can calculate dates and times. You can assign periodicity for time series. So I'm going to say, look, create a date time variable from a string containing date time. That's what I want. There is DOB. Look, it's giving me a little preview of the first few rows of data. So I can see, and I can say, well, that matches this pattern where you've got the day at the start, then you got the month represented by 3 letters, and then you got the four-digit year. I can go across this and I can call a new variable DOB2 as usual. I'm going to say I want the output in whatever format I want, but it will convert it now to a date field for me. If I go along here to the end, here it is at the end. This DOB2 as I did as beforehand. I didn't have to do, of course, my date at time wizard because you see I got away with it by just forcing it into a date type, but you don't often do that. So it won't often work because sometimes the formatting is just too special for it. So date and time wizard comes to the rescue there. We helps us helps us fix that problem. What else have we got as a result of this? Well, it says we've got some duplicate cases. It says you got 2 duplicates. It's cases with duplicate identifiers. Employee code 20, and these are cases 20 and 21. Let's go down and have a look at them. So this is employee code 20, 20 and 21. Look across here. So it says uh, these are duplicates. Look, see, they've been identified as duplicates belonging to group one. There was only one group in here. It's only 2 duplicates. They're both the same. If there was other duplicates, it'd be group two and group three. But everybody else has been labeled as unique. So you see these guys have been labeled as group one. You could sort this just by right-clicking the sort in order and just get all of the groups at the top and all the uniques at the bottom. But I've only got 2 here, so I can just manually remove one of them. I just need to make a decision which one I want to get rid of. I'm going to get rid of this one. It's got a capital F for the female group, and I'll just highlight the header and hit delete and just get rid of it, and that's that duplicate gone. What else do we have? What else has it found? Let's see, duplicate identifiers. I don't think there's anything else in here. Rows with a lot of missing data. Anything in here? Oh, incomplete identifier. Sorry, this one here, incomplete identifier. Case number 479 as an incomplete identifier. So if I scroll down to case number 479, right at the bottom here, I could jump down this. It's actually 478 because I've got rid of a case. I've got rid of a case already. So now it's case 478. But you can see it hasn't got any identifier with it. So I could say, look, you're actually case number 479. I happen to know, for example, let's say you're case number 479. So I've gone and looked you up, for example. So I've checked that person. Yeah, so that's useful. And rows with a lot of missing data. Anybody? Well, we can sort this in order again. If I say sort ascending order, and just make sure that just check and see if there's any cases down here where we've got a lot of missing data. Well, look at the bottom here. We can see that there's a lot of cases here these were not found to be non-empty. I forget. This is a gotcha I had. And because because I created my job time series mean variable earlier on, I forgot about this. These should have been identified as miss as data as rows where you have a lot of missing data. Everything's missing except for the ID. But because I've done my job time and created my series mean, it just put the series mean in there. So they flagged them as non-empty. If I ran that again, I could run it again. Let's do it again. Do validate data again. Click OK. Oh, look, it's found them. Oh, look, 476, 477, 478 at the bottom here. And we look at the bottom here. These are empty cases. Look, it says empty, so I kind of got myself out of hit delete. And I don't need these fields now because they've kind of done their job. They're just a way for me to try and mark the data in case there's lots of um, um, records or lots of variables that have lots of problems associated with them, and I need to find out where they are. Okay, so that's using validate data. Okay, we could rerun this and we could do it again. Okay, let's see if there's anything else that comes up here. Just check it, and I'll switch this off. I don't need these fields now. Click OK. Nothing coming through here in the validate data. This is all old stuff. These are all the old previous procedures. So nothing coming out there that looks fine. So nothing's failed those validation rules. So validate data, very, very useful to have. What about where we have non-legitimate ranges of values, where we have values which are kind of outside the range of values? Well, we can use validate data for that too. We can go down to validation and down to validate data, and I can go to something here called single variable rules. So single variable rules, this is really useful. I mean, just looking at these little charts it gives me is really useful. Because I can see some weird stuff here. It looks like gender's got more than two categories in it, which looks a bit odd. And I can see the minimums and maximums for all these different values down here. So that I can see, for example, somebody here has a education, number of years of education of 115 years of education. Well, there might be somebody in there who's got 112 years and 99 years, and that's obviously a problem. So I can define a rule, and I can call this rule EdCheck. Yeah. And I can say, look, education should be between 0 and let's be generous, let's say 30 years, something like that. Allow non-integer values within that range. So should somebody be allowed to put in 3.5 years? No, they shouldn't. So allow user missing and system missing values. Yes, I'll allow that. If I hit continue at that point, I need to actually tell it that one of these fields, education, should have this problem. So EdCheck is then flagged to apply that rule to that field. And then if I click OK at that point, you can see it's actually limiting the number of cases to 5,000. So it's scanning. It's actually taking a sample of them. If you've got like a million cases in there, you can switch that off, and it will just apply it to all of them. So it will, and then rescan it. It'll rescan it, apply it to all of them. If I click OK at that point and run it again, it says, all right, you got a field down here. It's employee code 147. Where you've got a problem at case number 147. Let's go down to case number 147. Where is it? There it is. And he's got 115 years of education. Let's say we've looked that person up and we find out they've got 15 years of education. So that's a single variable check. That's what that is, a single variable check. Is there a reorder feature in SPSS that records your actions and generates syntax like Excel macro? A recorder feature. Yeah, okay, yes, a recorder feature. Yeah, there is. First of all, this is the recall dialog box button, but also if you go to edit and options, if you go to file locations here, you will see that it's keeping a syntax journal file. That's all of your procedures that you've run. Of course, all your mistakes as well, but it keeps a syntax of everything that you're doing pretty much. And you can open that up and rerun it again. It would rerun everything that you've done since it started recording. I wouldn't rely on it too much. Not in the sense that it wouldn't do it, but it's just that there's a lot of mistakes you make. There's a lot of stuff you do iteratively. It is much better to hit paste as you're going along. So for example, when I do analysis in here, you saw me doing using date and time wizard here. If I did calculate with dates and times, and I said, okay, calculate the number of units between, I don't know, the date of birth and today's date, and hit that. You notice a lot of procedures just say I'm going to call it age today. You'll notice a lot of procedures like this. If I go along to this and it'll say paste syntax into a window, hit paste. So it pastes the syntax for you. And generally speaking, in SPSS, you have a paste button for a lot of procedures. The reason I was showing the formatting stuff here, and the syntax for the format, like, applying value labels and stuff like that, is because these buttons tend not to have a paste button. So things like, missing values, changing the name of a variable, applying value labels. They don't have paste buttons, but they do have syntax commands, and they will be recorded syntax. But pretty much everything else, everything that's got a dialog box, like, descriptive statistics here, look, it's descriptive. These are paste buttons. I'd rather people pasted their syntax as they're going along or wrote the syntax going along than using the journal file, because it's just going to be too. You're going to be scrolling back and forth between the journal file trying to find that bit, to run it again, and it's just too. It's not a good way to do it. It does do save points as you go along. So if you lose your data or something like that, or crashes something like that, it will restore from a save point, and that's something that's just come in recent versions. Okay, returning to data validation. We've so far looked at validating with a single check rule. There's a thing called cross validation. Before I get to validate with a single check rule, it turns out it actually has a bunch of its own validation rules, which you can load. So you can load predefined validation rules. If I click OK at that point, and then go to data validation, and then go to validate data. Look at these. All these validate rules have come up. So these are things like, making sure that the months stick to 3 characters, or that the full month has been recorded, or that sex has 1 character, male or female, or something like that. You got stuff for US states. You got stuff for Canadian provinces. Very useful, making sure that the UK postcodes, adhere to the postcode schema, if you like, of a space in between the postcode area and the remaining postcode sector and postcode area and stuff like that. And then even the coding for UK social class designation. So you can switch those on and apply them to variables and say, make sure that the postcode is correctly formatted. Another example here is what's called a cross variable rules, where there's nothing wrong with the variables per se, but they contradict each other. Now let's imagine that we've got 2 fields here. We've got something here called, I'm going to create a rule here called sal check. We've got 2 variables here referring to salary. One is people's current salary, and one is people's beginning salary. Now, it is possible that your current salary could be less than your beginning salary, because you become part-time, you get demoted or something like that. But let's just say, for argument's sake, that the current salary or the beginning salary should never be larger than the current salary. So local expressions should evaluate to 1 for an invalid case. So if I say beginning salary bigger than current salary, so greater than current salary, I'm just double clicking to paste them in. If there's any cases where that happens, that should evaluate to 1 for an invalid case, and I'm going to hit continue at that point. It's going to apply that and click OK. So this is for an illogical relationship. Click OK at that point. It says, yeah, case number 15. There's an issue there. Case number 15. We go and check it. They were on 33,000 when they began. They're on 27,000 now. So this is an error. Let's say we go and checked it up, and it should have been 13,500, something like that. We've gone and checked it. And then you just have situations where you have things like irrelevant data. So, you say there's groups and data in here, which when I'm right clicking and doing my checking and just checking the data as I'm going along, I notice, for example, that clerical custodial manager, we've actually got 3 people who've been classed as interns. And we don't really want them to be part of our analysis, for whatever reason, for this analysis session. So let's just get rid of them. We want to get rid of them. One way to do it is to find them and just sort in order. You could say just sort ascending order, and then just scrolling down, find the interns or something like that, and they're going to be down here somewhere. They are at the bottom. You could delete them. That'd be an easy way to do that. Or alternatively, sorting back in the original order. You could, if there's a lot of them and they're kind of scattered throughout the data or something like that, or there's more than one group you want to get rid of, you'd go to data, select cases. And you would say select cases if condition is satisfied and click if. And I'd say I want to get rid of the people who are in the intern group in this variable job cat. What's the code for them? Right click on it, check the variable information. The code is code 4. So I could say select cases if they're not equal to 4. Or I could say select cases if the code is less than 4, but not equal to 4 means just get rid of them. Same thing. Click continue and OK. That fires that filter, and it doesn't look like anything's changed. But if I look down at the bottom, if I try and find these guys at the bottom here, wherever they are in the data set, oh, they're in there somewhere. You will see they're obviously scattered throughout the data set. You will see that there's little strokes appear through the headers. I'll just have to sort this in order again to illustrate this. Sort ascending again, go to the bottom, control bottom. There you go. So these little strokes appear. That means they've been filtered out. So when I right click here and go descriptive statistics, they're no longer part of the analysis until that filter is switched off. But if I want to get rid of them permanently, I can go to data select cases again, or click my recall dialog box button, select cases, and hit delete unselected cases. Obviously, don't do that unless you're confident. I could do that, or I could create a separate data set and just move all of my selected data over to a new data set and say, no interns over here and put them over the net and then just work with that data set. But I'll say I'm confident this will work. So delete unselected cases, gets rid of them, and they're gone. It creates a filter field for you. It always marks the which cases were selected and which cases weren't. I don't need that field now, so I can just delete that. So that's how we might get rid of irrelevant data, and then we also find inconsistencies in data here. So if I find that, for example, I look at gender. Well, the codes for gender, the values for gender should be something like M for male. I'm just going to give them codes here, and F for female. That's what the case is. This is from the 1980s, this data set. If I then just check that and see if that's worked. Oh no, it hasn't worked. Look, we've got 3 cases where F was recorded as an uppercase F and M was recorded as an uppercase M. Now, with string data, and this is a string data, those are regarded as separate fields. Those are regarded as, sorry, separate values, separate, so that it won't see them, it won't see a lowercase f and a uppercase f as the same thing. So there's different things I could do here at this stage. I could do something clever. I could go to transform. Let's create a copy of it just to illustrate this and paste it. So I'm going to call this gender 2. Gender 2, that's just a copy of that. I could do something clever with something like this. I could go to transform compute variable. Actually, I didn't need to create a gender 2. I could have done this with gender 1. I'm going to say gender 3. I didn't actually need to create gender 2. Gender 3 is equal to, and gender 3 is going to be a string field. It's got a width of 1. It's going to have a label called sex of respondent, or sorry, sex of employee or something, gender employee. This is transform compute, and there is, of course, as there is normally with these types of systems, there's usually something that mucks about with string fields. So I could type in this thing called lowercase, a command called lowercase. So lower here. That will set everything to lowercase. So I could pick up gender here and say, let's pick gender 2. That's fine. Make that lowercase, and click OK at that point. And of course, I haven't got my capital. I haven't got my sorry, my value labels. So I could have overwritten this one. Let's try it again. Compute gender 2. Will let me overwrite it? Yeah. Let me overwrite it. There you go. So I don't need this. I could have just overwritten it. If I check it now, look, it's worked because it's just converted these guys, these F's and M's to lowercase. Sometimes it's not really the problem. It might be that there's irrelevant groups in there or inconsistently coded groups. So you might end up doing something like transform recode into different variables if you want to make a copy of it, or in the same variables if you're confident you want to overwrite it. And I could say I'm going to recode gender here into the same variable, and I'm just going to say, look, capital M should be lowercase m, add that. and capital F should be lowercase f, add that. All other values will just be ignored at this stage, and then click continue and OK, and then check it again, and we can see we've cleaned it up. So recoding, using recoding to collapse groups together, it's a really common thing you do where you get a lot of miscellaneous groups and data. And although they might be legitimate, there's not a problem with the data per se. You need to clean it up. So I'll often have more than one version of a variable. I might have region, and I might have region 2 and region 3 because we want to change the granularity. Or sometimes you have satisfaction variables, and you get a 7-point satisfaction scale. And you don't have a big sample, so when you're trying to split them by different groups, you find you've only got 3 people who are extremely unsatisfied, and 2 people in another group extremely unsatisfied. So you group together the extremely unsatisfied and the unsatisfied and the extremely satisfied and the satisfied. So you'd use a recode for that. Again, that would help. Now, if I open up my original data set, I've got employee for cleaning. I'm just going to open it up here. I've now fixed all of these ones. I'm going to revert to saved. I'm going to go to file output here and hit close that down. If I go to file open syntax, let's see if I got this somewhere in here. See demos, Smart Vision webinars, and data cleaning. Yeah, I've got my syntax. I've pretty much got a record of everything. I write down to getting the original data file, so I can close this and say I don't want a data file. Save file. So it starts with no data. A little bit of output here, just get rid of that. Just no data and the syntax, and I'll ask it to read the data file, rename the variables, apply missing values, change the type for job type to numeric, apply a variable label, change date of birth to a numeric field, delete the old date of birth variable and the city variable, remove the cases of no ID, identify the duplicate cases, delete all duplicate cases. And most of this I'm just clicking paste. I'm not actually typing it in. Most of it I'm just clicking paste. And then I can just go run all. I've recorded everything that just goes and does that and picks up the same data set beforehand and cleans it all up. And there's always going to be, you're going to get some stuff here where, it complains or says that data that, I couldn't, there's some missing values here. There's some missing variables here and something. There's some missing records here, but it works. It works perfectly well. And it's done its job. So we can see here that, we've got male and female cleaned up, and that, date of birth has been correctly formatted. Pretty much anything you need to do, you can do through syntax at that stage. Okay, let's see. It's if we just jump back out into the slides here to finish up, to come up to the end of the session. We looked at data cleaning with syntax there. You should be aware that there are additional resources. Everything from finding out what you have installed as to how to merge files, change the language, we've got some FAQs. We've got a bunch of video guides, how-to topics of mini demos, information on the products and the modules and the pricing, and Eat Your Green statistical series that gets kind of grounds people in the basics of statistics. Should be aware, as I said in the last page, we do offer consultancy, side-by-side consultancy, work on your data. Very common for people to give us the data set, us to clean the data set for them, build a syntax job for them, then teach them how we built that syntax job so that they can do this themselves. Training and support, of course, we have our own virtual training, we do customized training, and we do on-site training, whether it be full day or half day bite-sized courses, and we help with recruitment. We help you manage and source your existing SPSS licenses, and you can buy analytical software directly from us with discounts. And we offer no strings attached technical and business advice to all comers, whether they're customers of ours or not. We offer formal technical support around the IBM SPSS product family, ticketed support. And we offer access to our online training catalog for our customers, which is free for our customers. You should be aware that we have we have our own YouTube channel which covers this topic and covers many other topics to do with SPSS statistics and other platforms out there. In the next session, we're going to be looking at the basics of linear regression. If that's of interest to you, I think that session's at 3 o'clock. Feel free to sign up for it or take a look at our forthcoming schedule, a roster of sessions and webinars and sign up for them. We're just about to put together a calendar for next year's webinars where these types of topics will be covered again and other ones. In the meantime, thanks very much for logging in. We do hope you found it useful and look forward to you logging in again in the near future. Thanks.